Hi everyone, welcome to Vedantu JEE English. I'm Diksha, your chemistry master teacher. So everybody let me know in the comments section and chat box if I am clearly visible and audible to you so that we can start with a very important session for all the students who are preparing for VITEEE, right? So here what I am going to discuss today is the important concepts, right? Along with that, I'll discuss the questions based on that. Okay, so if you all are ready for that, then let me know in the chat box. Yes, students, if you all are ready for that, then let me know in the chat box so that we can start with this session without wasting any time. Yes? Okay, am I clearly visible and audible to you? Is the screen clearly visible to you? Because after when I start teaching the concepts, I might not be able to see the chat box continuously. So if you have any problem with the voice or the video, you can let me know in the chat box. Right? Yes, ma'am. For this session, most welcome, students. We are here to help you only. Right? Okay. So let us start this. Firstly, we are going to start with physical chemistry. So what I told you, I am not going to revise everything. Let's be clear, right? Everything I can't do in 1 or 2 hours, right? That's not possible, right? For that, you obviously know 1 day, 2 day, that you know, right? But here we are going to do the most important and most repeated concepts, right? So let us start with the first concept, that is Bohr model, right? So most repeated thing about Bohr model is frequently they ask you question regarding radius, velocity, then energy questions they ask, right? Now let us see what kind of questions they can ask you based on this, right? So first is, if you say that from radius, right, n, everywhere n will define the orbit number and z will define the atomic number, right? For hydrogen it is 1, for helium positive it is 2, for lithium 2 positive it is 3, right? And n orbit number will be given to you in the question only. Let's say if they give first orbit, that means n is equals to 1. Now you tell me in the chat box, if they give you first excited state, then what is the value of n here? What is the value of n for first excited state? If they give you simple first state, second state, third state, n is same. If they give you first excited state, second excited state, that means you have to add 1 to this number. So this is first, so it will 1 plus 1 is equals to 2. Second excited state is going to be 2 plus 1 is equals to 3. So you will add 1 to that number, that is going to be your answer for orbit. Okay, simple. Now here, if you see, directly they can ask you question based on this is the orbit, this is the atom, you have to give the answer, right, of the radius. From this formula, that is radius is in angstrom, I would prefer 0.5 to n square by z angstrom. Now, they can also ask you question regarding the ratio. 2 atoms will be given to you, 2 orbits will be given to you. They will ask you the ratio of this and this, R1 by R2, right? That they can ask you. For that, you don't need to remember this 52.9 or anything. Just remember that radius is directly proportional to n square by z, directly only this thing, right? Similarly, the question can be asked on velocity. The formula of velocity is this, and here the variability is velocity is directly proportional to z by n. For time period also, they can ask you the same question related to the ratios, and this is the variability. Time is directly proportional to n cube by z square. For energy, they can ask you question for first orbit, what is the energy, second orbit, the difference in the energies, delta E, all these things, and the conversion part. Obviously, you know what is conversion of electron volt to joules, but rather than, you should also know the direct formula, that is minus 13.6 z square by n square and minus 2.18 in 10 raised by 18 z square by n square joule, right? Now, if you say your total energy is coming out to be, let's say, minus x by 2, then kinetic energy will be, I'll just write it in a different form, right? Okay, if let's say this is x, if let's say this is x, then this will be minus of x. This will be minus of x. Okay, this will be minus of x, right? Okay, and this will be minus of, wait a minute, if I say this is x, right, then this is also going to be x, this is going to be minus of x, right, and this is going to be 2x. Okay, that is how also you can remember this energy conversions. Okay, energy conversions of kinetic to potential, potential to total energy, the conversion of energies here, right? Okay, now next thing we have is hydrogen atom. Now a very important question based on Rydberg equation. Okay, so firstly, what is Rydberg equation? This is your Rydberg equation, right? That is 1 by lambda equals to V bar is wave number equals to RH is the Rydberg constant, Z square is the atomic number, right? Okay, then you have 1 by N1 square minus 1 by N2 square. That is done, right? Now here, what kind of questions they can ask you? First is you should know what is the value of N1 and N2. Sometimes they will directly give you this is the value of N1 and N2, but I don't expect that in VITEEE, right? Rather, they will give you something like N1 is this, it belongs to Lyman series, Balmer series. So for that, you need to know what are exactly these series. So Lyman series, Balmer series, Paschen bracket P fund. That means N value is 1, 2, 3, 4, 5. Sometimes they can also give you that they will not give you that this belongs to Lyman series. Rather, they will say this belongs to UV region. That means this is Lyman series. They will say this belongs to visible region. That means this belongs to Balmer series. And infrared, they will not give you. Actually, they will rather give you directly Paschen bracket or P fund. They will not give you this belongs to infrared, because to infrared you have 3 things that are belonging. So we can't justify that statement, right? Okay. So now that will be the value of N1. Now second is, ma'am, what is going to be the value of N2, right? For the Rydberg equation. Now for N2, what we are going to do here, for N2, we should know these things here. That is, if you have, let's say, okay, for this, firstly understand this energy level diagram, okay? So when you put the value of N1, N2, N3, N4 in the energy formula here, you will get the values as minus 13.6, then minus 3.4, minus 1.51, minus 0.85. Now what you're observing here, that as the value of N is increasing, energy is also increasing here, right? As the N value increases, energy also increases. But here the value of delta E that decreases, that means the gap in the energies that will decrease, right? Here the gap is very large, it is almost 10 units difference, then the difference is 3 units, then it is something 1 point something, then it is 0 point something, that means it is decreasing as N is increasing, right? Now, next is, ma'am, through energy level diagram, see, simple thing is, for N2, either they will directly give you, then this is the value of N2, this is coming from Lyman series, 2N is equals to 4. Directly you can put the value of N2. But what if they give you, this is the first line, this is alpha line, this is beta line, this is second line, this is limiting line, this is last line. Now what you have to do, right? So first is alpha line. Okay, firstly let us understand last line. Last line will be where it is N is infinity, right? So last line or limiting line, that where you have N2 is equals to infinity, right? Here, why I am saying that it has maximum energy, maximum frequency, because it is the last line, okay? So the energy difference is very large, so it is maximum energy, and we know that E is equals to H mu, that means mu is also maximum, frequency is also maximum. We also know that E is equals to Hc by lambda, so lambda is inversely proportional, that is why minimum wavelength is there, right? Next we have is, if you have first line or alpha line. First line means it is next to the line from which it is falling. So if your N1 is, let's say this is N1, so N2 is going to be N1 plus 1, right? That is the first line or alpha line. Beta line or second line is, you have to add 2 here. Gamma line or third line is, you have to add 3 here, okay? You have to add 3 here. That is going to be your gamma line. Now next is from energies, how you will tell. See, we know that in this case, first line means if this is my N1, this is N2. That means the energy gap is very less. So it has minimum energy, minimum frequency, and wavelength is opposite. So it has maximum wavelength. From that, they can complicate this simple equation of Rydberg equation, right? By knowing this formula also, you may get confused in the exam, right? Next is, ma'am, if they ask you wave number, you can directly put the value of RH, because in that way you don't have to take the reciprocal of RH. But if they ask you the value of lambda, right, then you will have to solve 1 by 109677. So rather than solving that, what you do is put the value of 1 by RH as 912 Armstrong. In that way, you will get the value of lambda in Armstrong. Okay, right? Then you can easily convert it into centimeter, meter, nanometer, whatever is given to you, right? Okay, so that is the energy conversions. Next is a question based on number of spectral lines. So let's say they have given you a line is falling from, let's say an electron is falling from n is equals to 6 to n is equals to 2. So it will be 6 minus 2 plus 1 divided by 2. That is going to be the number of lines that are falling in between 6 and 2, right? In between 6 and 2, the number of spectral lines that you have. Now, these are the total number of spectral lines. What if they ask you specific spectral lines? That means they are saying you are coming from n is equals to 6 to n is equals to 2, right? But you have to tell that how many lines are falling to n is equals to 3. Okay, this is n is equals to 3. Now they have specified, they are not asking you all the lines. They have specified some lines. So whenever they have specified, drawing these lines, all of this is not important for you. You can't do that in the exam. You will get confused, and maybe after doing everything also, you will end up losing marks. You will end up marking the wrong option because you are in the panic state. So directly do it from the formulas. Right? Number of specific lines for specific orbit is n of high. It is coming from n is equals to 6. So it will be 6 minus n of specific is 3. So it will be 3 lines. Okay, that is going to be 3 lines. If that is clear to all of you, then let me know in the chat box. If that is clear to all of you, then let me know in the chat box that yes, ma'am, this page is clear to us. Right? Okay. Now, this also we have done. Right? De Broglie hypothesis. Right? Now, from here, what you have to remember? First is you should remember lambda is equals to h by mv. Right? All these formulas. Then you should remember that de Broglie hypothesis also prefers that, also says that 2 pi r is equals to n lambda. What is that? 2 pi r, because de Broglie hypothesis means dual nature. So this is from particle, this is from wave nature. And that's how you will get the Bohr angular momentum as well. That is mvr is equals to nh by 2 pi. So this formula, both are important for you. Right? Both are important for you. Next is hence Heisenberg principle. So in Heisenberg principle, directly the uncertainty in position and momentum is greater than h by 4 pi. And similarly, you can put the value of momentum here. Right? Okay. Now is the quantum numbers. How they will ask you questions from the quantum numbers. Right? Okay. Now, in this case, first thing is quantum numbers. You should know the principal quantum number. That is n. That is from 1 to infinity. Right? Azimuthal quantum number, that is from L is equals to 0 to n minus 1. Magnetic quantum number is from minus L to plus L. Minus L to plus L. Okay. Let's say if my L value is 2, so this will be minus 2 to plus 2. Okay. So next is spin quantum number, that will always be either plus half or minus half. Now here what you have to remember is, if you have 0 L, then it means it is S. L is 1, then it is P. L is 2, then it is D. L is 3, then it is F. Till F you should know. Right? Next is what they represent. From this theoretical question can be asked. Principal quantum number, that represents the size orbit. Right? Okay. And as it increases, right, size and energy will also increase. Azimuthal quantum number, it represents the shape. Shape of S, P, D, F, all are different. Right? S has spherical shape, P has dumbbell shape, D has double dumbbell shape, F has complicated shape. Right? Magnetic quantum number, that will tell you the orientation in the space. Right? Like you have Px, Py and Pz. Right? For P orbital, you have, for P subshell, you have 3 orbitals, Px, Py and Pz. So all these three orbitals are telling you the orientation in the space, right? Spin quantum number will tell you the rotation of that electron, whether it's clockwise or it is anti-clockwise, right? Now, one more question they can ask you based on the formulas directly from here, that is number of subshells. If they ask you, they have given you principal quantum number. They ask you number of subshells, that is simply n. Number of orbitals, when you have to represent this in the form of n, that is n square. Number of orbitals in the form of L, that is 2L plus 1. And in one orbital, you have 2 electrons. So number of electrons in that orbit will be double of this, right? That is why we'll just, you don't need to remember this formula or this formula. That will be multiplied by 2, right? Because in orbit, in one orbital, you have just you have just 2 electrons, right? Next is the angular orbital momentum. Formula is under root L plus 1 h by 2 pi. Angular spin momentum is under root F plus 1 h by 2 pi. Directly these questions they can ask you in your exam. Last concept from this chapter, which is very important for you, that is N plus L rule, okay? So from here, what kind of questions they ask you? First kind of question is that they can ask you that, one thing they can ask you, that they will give you some different orbitals, and they will ask subshells, they can give you different subshells. They will ask you that which of the following is high in energy. So what you have to see, that first you will match if N plus L, right? N plus L increases, energy also increases. But if N plus L is same, then energy will also be, no, if N plus L is same, then as N increases, energy will be increased. Right, so for example, you have 4s and 3d. Out of this, you have 4 plus 0, and this is 3 plus 2. So here it is 5, here it is 4. So that means this has more energy as compared to 4s. So we always fill the electrons in increasing order. So you'll fill the electron in 4s first, and after that you will fill the electron in 3d. Right? Okay. And if, for example, let's say your value of, let's say you have 4p and 3d. Right, now here it is 4 plus 1, that is 5. This is also 3 plus 2, that is 5. If your value of N plus L is same, in that case the value of N will define the more energy. So this has more value of N. So 4p is greater in energy. That is why when you write the energy level diagram, you write 4s, then you write 3d, then you write 3d, then you write, wait a minute, 4s, 3d is greater, right? Yes, then you write 4p here, okay? This is how it is written, okay? Understood, everybody? Now for hydrogen atom, if N value is same, then value of energy is also same. Energy is also same in that case. There is no difference in the energy, okay? 2s, 2p has same energy. 3s, 3p, 3d has same energy in case of hydrogen atom. Okay, is that clear to everybody? Yes, students. Now let us see the shortest wavelength of hydrogen atom in the Lyman series is lambda 1. The longest wavelength in the Balmer series is He positive. Now they are asking you what is the relation here, right? So here they have asked you everything, okay? So now here, shortest wavelength means lambda is very small. That means energy is maximum. Energy is maximum when N2, you can say N2 is equals to infinity. Lyman series means N1 is equals to 1, right? Balmer series means N1 dash will be equals to 2. And longest wavelength in Balmer series means, that wavelength is maximum. That means energy is minimum. That means the next orbit number, it will be your N2. So if this is N1 dash is 2, then N2 dash is going to be 3 here, right? So let us just put the values in your Rydberg equation and you will get your answer here, right? So this is your Rydberg equation. You just have to put the values in the Rydberg equation, right? What is Rydberg equation? Wait a minute. 1 by lambda is equals to RHZ square. This is 1 by N1 square minus 1 by N2 square. Okay. Now what you see here is, this is for hydrogen atom. For hydrogen atom, we know that Z value is equals to 1. For For helium atom, the value of Z will be equals to 2. So that is why here we have put 2 square, here we have put 1 square. Here we know that N1 is coming out to be 1, N2 is coming out to be infinity here. So when I put 1 by infinity, that will come out to be 0. Here it is 1 by 2 square, 1 by 3 square according to the N1, N2 values, and you solve these two. Now they are asking you the value of the longest wavelength in the Balmer series of this, that they are representing by lambda is equals to how much amount of lambda 1. This is what you have to calculate, that this lambda is how much times of this lambda that they have represented by lambda 1. So now you just need to take the ratio of both of them and solve it, that directly you can answer. Okay, understood everybody? Yes. Yes, students, let me know. Beta, please focus here on this slides, right? Rather than asking me questions regarding, ma'am, will I be able to do this or that? You can do anything. Yes, definitely. If you devote next 3-4 days totally into your preparation, then definitely that will benefit you. There is no harm in doing that, right? Okay, but I don't know you personally. What is your level? Your basics are clear or not? So I can't just generally say that yes, you can do that. No, it depends that if your basics are really strong, yes, you can definitely do that. If your basics are not clear, then I have no comment on that, right? So I'll be very clear. But if your basics are good, you have done your class 12th board also in a good manner, then definitely you can do that, right? Okay, then definitely these things are going to help you, right? And this session especially is definitely going to help you even if your basics are weak, right? Because I am focusing only on those topics where your basics might be weak, but I am focusing on those topics which are important so that I can at least lift you in those topics, right? Now here is the quantum number of 4 electrons are given below. The correct order of their increasing energies will be. So 2 questions they have asked in this one, right? So what you have to firstly see is what is the orbit number, what is this orbital they are talking about, subshell. This is going to be 4 SPD 0123 SPDF. Okay, so this is, they are talking about 4D here. This is 4D. This is 4P. Here they are talking about 3 LS2D, right? Here they are talking about 3P. Okay. So now here you have to solve these 4 things. That is 4D, 4P, or you can say 3D, then you have 4P, then you have 3P, right? Now calculate the value of N plus L here, right? So this is 4 plus SPD, I'll just write it here only, right? SPDF. So it is 2, that is 6. 3 plus 2, that is 5. This is 4 plus 1, that is 5. This is 3 plus 1, that is 4. So definitely they are going to have higher energies, right? Out of this, which will have high energy, 4P will have high energy. So that is why here what you can write, 4D, then you will have 4P, then you will have 3D, then you will have 3P. That is going to be the order of energy here. Now you have to put it over here, right? Okay. So 4D, that was belonging to 1, that is going to have the maximum energy here, right? Then 4P, that is the third, that is going to have less energy as compared to that. So order will be, fourth is your 3P, yes. So answer will be C is the correct answer, okay? That is how you're going to answer these questions. Is that clear to everybody or not? Right? So 2 major important topics. One is Bohr model, Rydberg equation, very, very important. Next is quantum numbers. You can't afford to skip these topics from structure of atom. Definitely you will see 1 or 2 questions from these 2 topics. Very, very important, right? Okay. Next is thermodynamics. Okay. Thermodynamics, you must have done this in physics also, right? So let me know in the chat box if sir has taught you in physics thermodynamics today, if he has taught you. If he has taught you in physics also, he has taught you all the things in detail for thermodynamics, I'll skip this in chemistry, right? So that we can focus on other parts, right? Everybody let me know in the chat box. Now, by the time you tell me, I'll start with some very basic things here, right? One thing for numerical that you should remember is at constant external pressure. At constant external pressure. What do you mean by that? Constant external pressure simply means that here we are talking about irreversible process. Whenever you see variable external pressure, in that case, we are talking about reversible processes, right? Next thing is first law of thermodynamics. In chemistry, it is delta U is equals to Q plus W, right? And W is minus P delta V. One more formula to remember is QP is equals to delta H and QV is equals to delta U. Very, very important formula. Now, always remember the sign conventions in chemistry. If you're using this formula, then work done by the system, if you have to do work done, you are negative. If someone is doing work for you, you are feeling very happy, you are positive. If heat energy is released, right, you have to give money to someone, you are negative. If someone is giving you the money, you are happy, you are positive, right? Okay. Then 4 processes here, isothermal, where delta T is 0, that's why delta U is also 0. Isobaric, delta P is 0. Isochoric, delta V is 0. Adiabatic, where heat energy change is equals to 0. Next we have is isothermal irreversible. These are the direct formulas that you should know, that in isothermal irreversible you will apply this formula which does not involve any integration, but for isothermal reversible you will apply this formula which involves integration. After integration we got this formula. Here it is log V2 by V1, this is log P1 by P2. Okay, whatever, whether they have given you pressure or volume, according to that you will apply any of these formulas for isothermal reversible and irreversible processes, right? Now, before coming to adiabatic process, firstly, I would like to teach you a simple thing regarding heat capacity. So, heat capacity questions are also very important. Directly formula you should know. Heat capacity is Q by T. If you talk about heat capacity at constant pressure, you will put P and P here. I have told you QP is nothing, that is delta H. Okay, and QV is nothing but that is delta U, right? Now here Cp and Cv are for n number of moles. But if I calculate the molar heat capacity, I'll divide this by n here. Okay, and it will be Cpm. This will be Cvm. M means molar heat capacity. So that's why I divided it by n. And from that you get this very, very important formula, that is delta H is equals to n Cpm delta T. This is very important for your VITEEE. We have seen direct question from these two formulas, direct questions, okay? So delta U is equals to N CVM delta T, right? Heat capacity is a very important topic for you, right? Delta U is equals to N CVM delta T, where this N is number of moles, CVM is molar heat capacity at constant volume, CPM is molar heat capacity at constant pressure, okay? Now, specific heat capacity is not at all important for you, right? For specific heat capacity, rather than dividing it by number of moles, you will divide it by mass. That is specific heat capacity, right? Now, next is you should remember is what is gamma? That is Poisson's ratio. That is Cp by Cv. Or you can also write it like this: Cpm by Cvm, where Cvm is Fr by 2, Cvm is R plus Cvm. Right? Okay. Yes. Okay. What do you mean by that? Simple is, when you're calculating the value of gamma, you need CPM and CVM. CVM you will solve from degree of freedom. That means, what if they give you monatomic gas? Then degree of freedom is 3. Diatomic or linear polyatomic gases like CO2, you will have degree of freedom as 5. If they give you non-linear polyatomic, you will have SO2, like SO2, degree of freedom will be 6. According to that, you will have the value of CVM when you put it here. And when you add R into it, you will have the value of CPM. You divide it, you will get your value of gamma that I have written already here. These values are extremely important for you, right? Then, this formula is very important. Usually what students learn is Cp minus Cv is equals to R. No, Cpm minus Cvm is equals to R. Cp minus Cv is equals to Nr. Right? In NCERT, it is written like this. Cp minus Cv is equals to R. But there they have written in the bracket that this is for 1 mole. Yes, for 1 mole, Cp minus Cv is equals to R. But why can't we write for 1 mole Cpm minus Cvm? Right? Because we usually skip the things that are written in the bracket. So rather, learn this CPM minus CVM is equals to R, right? Okay. Now I'll just go through the formulas again. For adiabatic, directly W is equals to N CVM T2 minus T1. CVM you can easily calculate from the gas that will be given to you, right? Okay. Number of moles will be given, delta T will be given. They can also ask you two other things, that is temperature, right? If they ask you irreversible adiabatic process, temperature you can solve from this equation, where all the other terms will be given to you except for T2, okay? Or if they give you reversible adiabatic process, directly you can solve this or this formula will be applied depending upon what they have given you, whether pressure or volume, or pressure or temperature or volume. According to that you will use any of this formula, but you should know the value of gamma here. Okay, why you should know the value of gamma? Because gamma will be given to you whether it's diatomic, monatomic. According to that you will get to know which is the value of gamma here, right? Okay, then the next part is last part of this chapter, that is this equation, very important for you. That is, if you want to be risk free, you are thinking, ma'am, work done I find very difficult. Ma'am, tell me what are the most important concepts here. They say everything is very important. They ask you very simple questions from thermodynamics, right? But still, if you want to see that, these two equations, this equation and this equation, are very simple yet very important, right? Okay. So here directly all the values are given to you in the question. You just have to put this. This formula application is very simple, right? So here, if pressure and volume is given to you, either this or this formula will be applied. If they have given you any reaction, in that case, you will apply this formula, right? Where delta Ng, R value you already know, that is 8.314. Temperature will be given to you in the question. Either they will ask you delta H or they will ask you delta U, right? Now, one twist they can do is, instead of delta H, they can write QP. Instead of delta U, they can write QV. They will ask you, what is the heat energy at constant volume? That means they are asking the value of delta U here, right? Then enthalpy positive means endo, enthalpy negative means exo. That we all know, right? Not a big deal. Now let's come to Gibbs-Helmont equation. Very important. Now delta G is equals to delta H minus T delta S, where this is entropy, enthalpy, this is Gibbs free energy. Now they can ask you, like, for a spontaneous reaction, what is the temperature? Delta H and delta S will be given to you, right? For a spontaneous reaction, delta G should be less than 0. According to that, you can solve it. Or they can give you all the values. They can ask you delta G. They can ask you delta H. Anything they can ask you from this Gibbs-Helmont equation, right? Okay. Now, let us see some question based on this, right, everybody? 5 mole of an ideal gas at 100 Kelvin. Everyone, let us see this question. Yes, students, VITEEE, yes. Now, 5 moles of ideal gas at 100 Kelvin are allowed to undergo reversible compression till its temperature. Achha, wait a minute, I forgot to tell you one important part, that is these things, okay? Isobaric process, pressure is constant, so directly this formula will be applied, that is a general formula. Isochoric process, volume is constant, so that is why work done will be 0, because delta V is going to be 0. For cyclic process, it is area under the curve, but for clockwise, it is work done is negative. Anti-clockwise, work done is going to be positive. Open vessel, directly you will say open vessel, work done is equals to minus delta NGRT. Directly you will solve this with this formula, because PV is equals to nRT. That's why instead of PV, we have put delta NGRT. In this case, one reaction will be given to you in the exam. Okay. Free expansion, all the terms, work done, delta U, Q, all the terms are going to be 0 in this case. Okay. Yes, students. Now let us see this question here. 5 moles of ideal gas at 100 Kelvin allowed to undergo reversible compression till its temperature become this. Okay. Calculate delta U, delta PV for this process. Two things they are asking you to calculate here, right? Okay, temperature will change definitely here, right? So 5 moles of ideal gas, this they are asking how to do reversible compression, right? Okay, now CV is given to you here, right? CV is already given to you. So from the formulas directly you will solve this, right? From all the formulas that we have now done. Now I taught you that delta U is equals to NCV delta T. You will say, ma'am, you to told NCVM. Ma'am, here they have written NCV. Usually, see, what they have written, if CV is equals to this per mole. Per mole means they are talking about CVM. Okay, these are the little things that you need to see in the exam, right? So it is CVM and CVM delta T. Delta T is given to you, number of mole is given to you, CV is also given to you, right? So you just have to put these values and get your answer here, right? Because the answer of delta U is given in kilojoules here mostly. So you'll have to convert this into kilojoules and you will get 40, right? Now, we also know that PV is equals to nRT, right? They are asking you the value of delta PV, right? They are asking you the value of delta PV. So delta, put delta here, this is PV. Number of moles is not changing, this will be N. R is not changing, but temperature is changing. So this will be nR delta T, right? So it will be nR, put the value of N, put the value of R. Here I had directly put it as 8, right? Okay, this is basically 8.314, right? And T2, T1, you can put the values here and again you will get your answer directly here, okay? So direct formula based questions, right? If you see, it's not a difficult question, okay? It's not these are the kind of questions that are focused in VITEEE, right? So it's not like they will ask you very tough questions, right? They will ask you simple questions from thermodynamics. You just need to know the formulas, right? If they are on your tips, definitely you will be able to survive your thermodynamics. A gas is allowed to expand in a well-insulated container. Now, insulated container means Q is equals to 0. This is adiabatic process, right? Against the constant external pressure. Now, you tell me constant external pressure, whether it's reversible or it's irreversible. Yes, students, is it reversible or it's irreversible? You tell me in the chat box. Of pressure is this, pressure is given to you from initial volume, V1 is also given to you, right? V2 is also given to you. The change in the internal energy of the gas. See, first thing is delta U is equals to W plus Q. If Q is 0, then internal energy is equals to work done. Now, ma'am, you have taught us that work done is equals to NCVM delta T. But there is no mention. See, if in the question, rather than giving you pressure and volume, they would have given you CVM, they would have given you number of moles. I would say calculate it this way only. Calculate it this way only. Apply this formula, calculate the value of delta U directly, right? And that will be your work done. But here they have not given you CVM or N, right? So what you will do? This formula, work done is equals to minus P delta V. Okay. So pressure is given to you, right? And volume you already know. So directly you can put the value formula here, minus P. Pressure is 2.5, right? And this is delta V is, this is 4.5 minus 2.5. You can put these values and you will get your answer. But understand the answer is in joules. So you have to, this will be in liter atmospheric. So you have to multiply this by 101. Then you will get your answer in joules here. Okay. Right, the conversion part is very good. Students have told, ma'am, constant external pressure. Constant means a big external pressure you have used, right? So a big external pressure, that means we are talking about irreversible process. Okay. When you have variable external pressure, when you have small steps, that is a reversible process. Okay. So this is irreversible process. Okay. Next you have is a equilibrium. Okay, let's revise equilibrium, the important concepts here of equilibrium. See, chemical equilibrium, ionic equilibrium, that is a very big chapter, very big chapter. So what are the most important things to do here? right? So first thing, students, in ionic equilibrium, just focus on the pH formulas, right? If you ask me, ma'am, what are the most important things? pH formulas and solubility product. pH formulas of everything. If you're like, ma'am, right now I don't have time to understand the concept, go through the pH formulas, okay? Most probably you will be able to answer the questions, okay? First is for equilibrium. We know that the Kc is product raised to power the stoichiometry divided by reactant raised to power the stoichiometry, right? This is not even a new formula to you, so I'm not going to revise these into formulas for you, right? This you have done already in boards, right? So many times. These are the important things that you must do for your competitive exam. That is, let's say if the reaction is reversed, right? If reaction of A to B is K1, then B to A will be K2, then the equilibrium constant will also be inversely proportional to each other. If you multiply the reaction with some digit, with some number, then that number will be in the power of the original equilibrium constant to get your new equilibrium constant, right? If you divide it with the some number, in that case, your new equilibrium constant will be equals to the old equilibrium constant raised to power 1 by that number from which you divided it, right? So it was basically divided by 1 by n. That's how you get K1 raised to power 1 by n, right? Next is if you add two reactions, their equilibrium constants will be multiplied to generate new equilibrium constant. If you subtract two reactions, their equilibrium constant will be divided to generate new equilibrium constant. Okay, is that clear? Is that clear? Is there any problem on this page? Any problem on this page, students? Now, I'll just pick up one question so that you're able to understand what exactly we are doing here, right? Okay, I think not this question. This was the question, okay? Right, because in equilibrium, there are a lot of concepts, okay? So that's why one by one, I'll teach you what with the concept, with the problem, right? So that you are able to understand what I'm telling you. Consider the following reversible chemical reactions. Two reactions are given to you. That might seem easy for you. Now, this might seem, oh my God, ma'am, what they have asked. Actually, it's a very simple thing. Let's say this is the first reaction, which is K1. Now, when you multiply this by 3, and then you reverse it. When you multiply this by 3, that means K2 is equals to K1 raised to power 3. When you reverse it, it will be 1 by K1 raised to power 3, that is K1 raised to power minus 3. So answer will be K2 is equals to K1 raised to power minus 3. So answer is going to be C is the correct answer. Is that clear to everybody? Right? Okay, C is the correct answer. Those who have answered A, they forgot that there is also reversibility. Here you have A2, B2 on the reactant side. Here it is on the product side. So you have also reversed the reaction, right? So equilibrium constants will also be inverted here, right? So answer will be C is the correct answer. So based on this concept, a very simple question they will ask you, but this has a very, very high probability of asking, right? Okay. Then next is this formula, right? Okay, this formula, that is log K2 by K1 equals to delta H 2.303 R T2 minus T1 by T1 into T2. So if they have given you, let's say at this temperature, this is the equilibrium constant, at this temperature, this is the equilibrium constant, whether this reaction will be endothermic or exothermic. That means you have to calculate the value of delta H from here. If that is positive, that reaction is endothermic. If that reaction is negative, it is exothermic in reaction. So very simple, right? Then one more question they can ask you based on QC and KC, right? So they will not ask you this QC is greater than KC, whether this will be backward or forward. No, that's a very simple question. They will not ask you that, right? If they ask you that, that means they are giving you free numbers, right? So rather what they will say, QC value is, let's say X, right? Let's say something, I'm just randomly 1.8, right? KC value you have to calculate by this formula, product raised to power concentration, reactant raised to power concentration, right? So this Kc value, let's say it is coming out to be 2. In that case, you have to tell, okay, Kc is greater than Qc. If it is coming out to be 1.6, then Kc is less than Qc, right? So according to that, they will ask you if they want to ask a tough question. Okay. So now here, don't spam, students, don't spam it in the chat box, don't spam. Okay. Right, there is no benefit of you and me as well, right, when you spam things, right? Okay, I'll definitely see that what you're saying, right? So QC, if it is here, KC is fixed, okay? If QC is greater than KC, you have to match this value while coming backwards. So that's why it's a backward reaction. If QC is equals to KC, that is at equilibrium. If QC is less than KC, you have to move forward. That means it is a forward reaction. Okay, understood everybody? Now, next is a relation of delta G and K equilibrium. Direct question based on this formula. That is delta G is equals to minus 2.303 RT log K equilibrium. Right? Directly numerical based questions they can ask you. Also, you should know that if Kc is greater than 1, right, then delta G is obviously negative. If Kc is less than 1, if this is less than 1, then delta G is going to be positive here, because log of less than 1 is going to be negative, right? Okay, that is why this log is going to be negative in that case, and hence delta G will be greater than 0, right? If Kc is equals to 1, because log of anything is equals to 1, log of 1 is equals to 0, right? That is why delta G will be 0, and that's why this is at equilibrium, right? Okay. So now, when delta G is negative, it is spontaneous. That is why reaction will itself proceed in the forward reaction. If delta G is positive, it is a non-spontaneous process which does not want to occur. That is why it will be a backward process. If delta G is 0, it is at equilibrium. There will be no shift here. There will be no shift. Then you have Lee-Chartlier's principle, right? Okay, Lee-Chartlier principle. How many of you find this topic difficult or easy? Let me know in the chat box. Okay, knowledge B, I'll take care of that. Right now, please focus here, right? Lee-Chartlier principle. So students, now here, mostly the question is asked on pressure and temperature, right? But you should know all the cases here. First is the concentration. It will always go in the opposite direction, whatever you do. That is Lee-Chartlier principle. It's a stubborn kid. Your mom will say, don't do this. This will do that thing only, which mom is saying not to do, right? So it's a stubborn kid. So here it is concentration opposite to the, if you, let's say you increase the concentration of reactant, it will try to decrease it by moving it forward. So it will be a forward reaction. That's how it is going to change. But if you add any solid component, there is no effect on that. Solid component has no effect. Then talking about pressure here. Pressure and moles are always opposite. So if you increase the pressure, it will go in the number of moles where number of moles are less. When you decrease, it will go in that direction where number of moles are more, right? Volume change. Volume is inversely proportional to pressure. So when you increase the volume, it will go in that direction where number of moles are more, right? Okay, because here when you increase the pressure, it is going in that direction where number of moles are less. So volume is opposite. So when you increase the volume, it will go in that direction where number of moles are more, right? Then talking about temperature here, directly what you will see, if temperature is exothermic or it is endothermic. If temperature, you see if the reaction is exothermic, delta H is negative. In that case, when you increase the temperature, rate, this equilibrium constant decreases. So it is a backward reaction. In this case, when you increase the temperature, equilibrium constant also increases. So it is a forward reaction. So it depends upon whether the reaction is exothermic or the reaction is endothermic, right? Okay. Next is inert gas. I feel that right now they can also ask you very simple questions like this. At constant pressure, when the pressure is constant, number of moles are more, okay? At constant volume, there is no effect. But at constant pressure, it will go in that direction where number of moles are more, okay? Then you have volume. This we have already done. These are some of the examples where reactions are positive, exothermic or endothermic in nature. Like combustion is always exothermic, decomposition is always endothermic in nature. Okay. Next, students, we have everybody. Next is strong acid. Now, I'll tell you directly here what are the questions that they might ask you based on pH. Okay. So, pH is equals to, firstly, you should know the value of pH here. I'm just going to write it here. The value of pH will always be minus log of H positive of solution. Right. The value of POH is going to be minus log of OH negative of the solution. Right, and the value of pH plus POH is going to be equals to 14, that you should remember. Right, now what if they have given you simple strong acid? In that case, you will take the concentration of that strong acid. If it is greater than 10 raised to minus 6, you will ignore 10 raised to minus 7 here. If it is less than 10 raised to minus 6, you will add 10 raised to minus 7, which is from water. Because water also has H positive, right? Okay. After putting the H positive value, taking the log negative, you will have the value of pH. Similar is for OH negative. If it is greater, then you will have to ignore 10 raised to minus 7. If it is less, then you can add 10 raised to minus 7 here. Now, pOH is also, you will take it the same way, right? Next is, if two strong acids you have. If you have two strong acids, directly what you will put? N1 V1 plus N2 V2 by V1 plus V2, where this small m are representing the N factors. N factors. Like for HCl, there is one H positive, so N factor is 1. For H2SO4, there is 2 H positive, so N factor is going to be 2. Similarly, for base, if you have two strong bases, it is N1 V1 plus N2 V2 divided by V1 plus V2. That is going to be, right, the correct answer, right? Okay, right. Next is strong acid. Now, this is very, very important. That is strong acid and strong base. If you have one strong acid and strong base, let's say here there are choices whether you will use OH negative or H positive. Let's say your OH negative, your base is greater, right? Or you can also write it like this: larger minus smaller value divided by V1 plus V2, right? That will be the answer. And if I say that for acid N1 V1 is greater, right, then you are calculating H positive concentration. If for base N2 V2 is greater, then you are calculating is more, then you are calculating OH negative concentration. So let's say if your N1 V1, that is for acid, it is more, then you will calculate H positive because acid is more in quantity, right? If M2 V2, that is for base, it is more, then you are left with only OH negative. That means you are calculating OH negative ions here, right? For weak acids, you can skip all these things, right? I'll tell you, you can skip all these things because that is nothing but that is a ratio of the same thing. But you should not skip is this formula Ka is equals to C alpha square. This is for weak monoprotic acid, right? And pH is equals to half pKa minus log C. These two are the important formulas for you. Next is for buffer solution, what you should remember is you have acidic buffer, you have basic buffer, you have salt buffer. Here what you can understand is the formula for acidic buffer, the formula for basic buffer, and the formula for salt buffer. Directly put these formulas here when you will calculate pH plus pOH is equals to 14. So you can calculate pH value is 14 minus pOH. Directly you can solve the value of pH as well here, right? Okay. Now let us understand for salt hydrolysis. For salt hydrolysis, see, you have three kind of things. One is you have weak acid, strong base, strong acid, weak base, weak acid, weak base. In all these three things, what you have to remember is the pH values here. So the pH values you should remember from here. Okay? If you have weak acid plus strong base, this is the pH value, that is 7 plus half pKa plus log C. If you have strong acid plus weak base, this is the pH value, right? That you should remember. Directly remember the pH values, right? Okay. These are the tricks that I have already told you in physical chemistry formulas. You can go through that. But here I am directly telling you the pH values here, right? For if you have weak acid, weak base, this is a direct formula of pH. Direct pH formula is very, very important for you. Then last important topic from ionic equilibrium is solubility product, which is very important. So if they have given you some reaction like this, okay, this is the stoichiometry, this is the stoichiometry, it will be x raised to power x, y raised to power y, solubility x plus y, that is going to be the value of Ksp, that is the solubility product, right? Next, if you have common ion effect, let's say this is CF2, it is also giving us Ca positive and 2F negative, right? And NaF is also giving you F negative. It is giving you 0.1 and it is giving you, this is S00, 0, this is 0. For stoichiometry, it is S. For stoichiometry 2, it is 2S. Now here it is giving you 2S F negative. From here it is 0.1, here it is 2S. So you will add 2S here. You will add 0.1 here, and hence this is the final F negative concentration what you will have. But solubility is very less as compared to 0.1. Like we always ignore alpha value in place of 1, right? So here we can ignore the value of solubility. That's why answer will be 0.1. Directly you can solve Ksp is equals to concentration or solubility of this, that is Ka2 positive, that is solubility raised to power 1. This is 0.1 raised to power 2, that is the stoichiometry, and you will get your answer for Ksp. But remember one thing here, that very important thing, if you don't have common ion effect, you will directly use this formula. If you have common ion effect, you have to go through this application. You have to go through this proper steps. Okay, you have to follow all these steps here if you have common ion effect. This is a very, very important topic. Okay, understood everybody or not? Now let us do some questions based on this. Everybody, right? Yes, definitely you will get the session PDF. Now let us see the questions based on this. That is, at 500 Kelvin for a reaction, this reaction is given to you. Kp is this much. What is the value of Kc? So directly this is the relation of Kp and Kc. This is the relation, right? Kp is equals to Kc RT delta Ng. Delta Ng you will get to know from the equation, that is 2 minus 4, product minus reactants, that is minus 2. Put this value and you will get your answer. This formula is also very important. Next question is from Lee-Chartier principle. Now this formula is given to you. Now you can see this equation is exothermic because heat is getting released. Now they are asking you which will favor forward reaction here. Forward reaction means, let's say if I increase the temperature for an exothermic reaction, temperature and equilibrium constant are inversely proportional, so rate constant will decrease. For equilibrium constant will decrease. That means if temperature increases, equilibrium constant decreases. That simply means one thing, that it will go in backward direction, which we don't want. So that's why we need low temperature, so that equilibrium constant increases. That will go in the forward direction. So low temperature is preferred. Whether low pressure or high pressure, that depends upon the moles. So less moles are there on the product side. That means if you increase the pressure, because as pressure increases, it will move towards less moles, that is forward direction. So answer will be low temperature and high pressure, right? Next is the incorrect match in the following. Incorrect match, see, simply is K is equals to 1. We know that delta G is equals to minus 2.303 log of Kc, right? So that means if you see that Kc, if it is 1, then delta G is equals to 0, that is correct. If Kc is greater than 1, then delta G is negative, that is also correct. If Kc is less than 1, then delta G, this whole term will be negative, delta G will be positive, that is also correct. If Kc is less than 1, delta G is negative. That is incorrect. So answer is D is the correct answer here. Okay. Yes, students, everybody, let me know. Next question is based on, let me see. This question is a very interesting question. Okay. Now let us solve this. After that, we are going to start with the physical chemistry of 12th class. Okay. Everybody in the chat box. Everybody in the chat box. So let us see that 20 milliliters of 0.1 molar H2SO4 solution is added to 30 milliliters of this much NH4OH solution. Now, can you tell me what is the value that basically you have to calculate? The pH of the resultant mixture. pKb of NH4OH is 4.7. Okay. So as you can see, this is a strong acid. This is a strong acid. And NH4OH, let me know in the chat box whether it's a strong acid or weak base. Now, if you see, the reaction takes place when H2SO4 is added to NH4OH is as follows. We know that this is a question of strong acid and a weak base. Now, it's not strong acid and strong base. So, you can't just directly apply N1, V1 minus N2, V2 divided by V1 plus V2. No, that is for strong acid, strong base. If you have any of that is weak, now you have to identify whether it's a question of salt analysis, like whether this is a question of salt hydrolysis or buffer solution. Okay, that we will analyze here. Now, if you have strong acid and weak base, the salt is of strong acid and weak base, right? Strong acid and weak base. Now tell me, if you have strong acid and weak base, that is nothing but resulting solution is a basic buffer, right? For example, you had salt of strong base plus weak acid, then it would be a acidic buffer. Now this is a basic buffer, right? Okay. Now here, directly what you will do, you will use the formula of basic buffer here, that is POH is equals to PKB plus log of that salt divided by the base. If you remember this, wait a minute, let me just show you here. Basic buffer where you have, okay, wait a minute, yes, okay. This is the basic buffer. POH is equals to PKB plus log of salt by base. This is the formula that we are using there. Okay, this is the formula that we are using there. So the main important part is to know that this is a question of buffer, right? Okay, then you will put this value of salt. Everything is given to you in the question only. 20 milliliter of this much mole is added to 30 milliliter of this much mole. So concentration is already given to you. That is 2 plus 2. This is already given to you concentration, right? And PKB is also given to you in the question, that is 4.7. So what you will do, you'll just put this value here and you will get your answer here. pH is equals to 14 minus POH. So 14 minus 4.7, answer will be 9.3 is the correct answer. If that is clear to everyone, then let me know in the chat box, because this is a very, very important question. Mark it, very, very important question. Okay. Understood? Yes, everybody? Yes, everyone? If that is clear, then let me know in the chat box. Right? Okay? Yes? One more thing. In this case, the concentration when you are adding, you have to be clear on one thing, that millimoles at temperature 0, this is volume multiplied by this, that is 2. Here it is, weak base is given to be 30 multiplied by 0.2, that is 6. And in this it is 0. So what will happen here? All of this will be eliminated. This will be, all of this will be consumed here, right? Here you will have this, and here 2 of this will be consumed. You will have 2 left and 2 left. So in the end, you have weak base, that is 2, and weak acid, that is 2, because you have to look for the stoichiometry as well here, right? The stoichiometry is 2. Here the stoichiometry is 1. Here the stoichiometry is 1. Okay. For that, you will put this value and you will get your answer here, right? Next is solution chapters. Everybody, let us see the solution chapter here. Now, solution electrochemistry, chemical kinetics, I would say these are very simple chapters, right? Basic questions are asked here from colligative properties, Nernst equations. So directly, let's go through that. Raoult's law, firstly, you should know Raoult's law is partial pressure is equals to pure vapor pressure multiplied by the mole fraction. That is your Raoult's law. Okay. Next is, see, the one that follows Raoult's law are the ideal mixtures, right? These are the examples of ideal mixtures which are almost look alike. They have just difference of one atom, or maybe they are homologous of each other, right? Then, one thing to remember in this case, always remember delta H and delta V mix is 0, but delta S and delta G, okay, always delta G is going to be negative, always delta S is going to be positive. It doesn't matter whether it's a ideal solution or non-ideal solution, right? Now let us see the examples of non-ideal solution. There are two kind of deviations that you have. One is positive deviation, other is negative deviation. For positive deviation, right, the pressure is greater than what we expect from Raoult's law. From negative deviation, the pressure is less than what we expect from Raoult's law. So in positive deviation, what happens? The interactions are less. The interactions of AB are less as compared to AE and BB interactions. And in negative deviation, the interactions of AB are greater than AA and BB interactions. And here also, because it's a positive deviation, delta H and delta V is positive, delta H and delta V are negative. Delta S and delta G, as I told you, that is going to remain the same. That is, entropy is always positive and Gibbs free enthalpy is always negative. These are the examples of the positive and the negative deviations, which are very important. You hear what you will see? Interactions is decreasing. Water is breaking the hydrogen bonds here, right? Here, water is forming the hydrogen bonds between this, so interactions are increasing here, right? Okay. Then there is bond-Hoffe factor, right? Bond-Hoffe factor, simply you can just ignore these formulas here. You can ignore these formulas, they are not useful for you. Just remember, if bond-Hoffe factor is greater than 1, it is dissociation. If it is less than 1, it is association. If it is equals to 1, that it is neither association nor dissociation. That is in the case of non-electrolytes. That is in the case of non-electrolytes like glucose, like you have urea, right? All these are non-electrolytes. Now let us see the colligative properties here. First is relative lowering in vapor pressure. That is delta P minus pure vapor pressure is equals to I, bond-Hoffe factor will always be added, into mole fraction of the solute, right? Then you have elevation and boiling point, that is delta TB is equals to I into KB into molality, right? What is molality? Molality is equals to number of moles of solute W2 by M2 divided by weight of solvent multiplied by 1000. What is molarity? Molarity is number of moles divided by volume. If the volume is in milliliters, then it will be multiplied by 1000. Okay, this is your molarity. This is what we say is molarity, right? Now that Kb is ebullioscopic constant, Kf is cryoscopic constant, right? Then next is osmotic pressure, in which this C is nothing but it is molarity. It is nothing but it is molarity. Pi is equals to ICRT, right? Okay, understood? Isotonic solutions are those in which pi 1 and pi 2, that means the osmotic pressure is equal, that is called isotonic solution. Next is Henry's law, in which we have pressure is equals to Kh, that is Henry's constant, multiplied by the mole fraction, that is called as Henry's law. That solubility and pressure are directly proportional to each other. Okay, understood? Now let us do one question based on this, what we have. A solution is prepared by dissolving 0.6 gram of urea. So how to visualize the colligative properties, right? How to understand this question, right? Osmotic pressure they are asking you, that means pi is equals to CRT you have to apply. C is molarity, right? Okay. Now I'll see urea means I is equals to 1. Van Hoff factor is equals to 1. Right? This they have given us the weight of urea. Molar mass we know. This much of glucose in 100 milliliter of water. A solution is prepared by dissolving two things. One is urea, other is glucose in 100 milliliter of water. The osmotic pressure of the solution is this. Now you have two solutions here. One is urea and one is glucose. Both we are mixing here, right? So concentration of both will be added here. For what we see, we know that this is the relation. Given mass of urea is given to you, molar mass is given to you, mass of glucose is given to you, molar mass is given to you, right? Now here, for this N, that is number of moles, both the values will be added for urea and glucose both, right? So here number of moles is going to be 0.6 by 60. Here it is 1.8 by 180, right? Okay, this is what you will add here. This is going to be 0.01. This is going to be again 0.01. So here answer is going to be 0.02. That is 0.02. Number of total moles, that is N1 plus N2, is going to be 0.02. Right? Volume is already given to us in the question. That is, volume is given to us as 100 milliliters. Okay, volume is already given to us 100 milliliters. Right? Now RT you have to multiply. Now students, ma'am, why we have multiplied it by 1000? See, in this part, if you see this equation here, I told you, whenever you are putting molarity and you're putting volume in milliliter, you have to multiply it by 1000. That's why you multiplied it by 1000 here. Okay, that's why it is multiplied by 1000, because this is in milliliters, this is R value and this is T. Ma'am, why the value of R is 0.0821? Because whenever you are talking about volume, pressure, then the value of R will be 0.0821, that is 1 by 12. Okay, understood this, right? Okay, very good, very good, very good, which does not depend on the quality, instead the quantity. Very good, that is colligative property, right? The next one we have is chemical kinetics. So from here, two most important things are first order reaction and Arrhenius equation. These are the two important topics here, okay? So first is these important things regarding the rate. Two things I'll tell you here. One is, if you calculate the rate from the reaction, rate of the reaction, in that case it will be divided by the stoichiometry, right? So whenever I am calculating the rate, I am dividing it by the stoichiometry. I am dividing it by the stoichiometry. If you are talking about in terms of reactant, you will put a minus sign. If you are talking about products, you will put a plus sign, right? If you are talking about rate of appearance or disappearance, in that case, you will not divide it with the number of moles. Only the rate of reactions will be divided by the number of moles. That is the important part. Next important thing is, let's say rate of reaction you have, okay? Let's say rate of reaction you have. Now students, rate of reaction, this is 1 by B, dB by dt. Wait a minute. Here your product is appearing and this is getting disappeared. So it will be negative here. Okay. This will be negative here. Wait a minute. This will be negative here. Okay. This will be negative because reactant is getting disappeared. So it will be minus 1 by A dA by dt. Right. Rate of appearance will be plus dB by dt. Right. Disappearance will be minus dA by dt. There is no division with the number of moles. Next is, what is order? Order does not depend on the reaction. See, it will depend on the rate equation. If this is the equation, then x plus y is going to be the order of the reaction. That depends on the stoichiometries in the rate law equation. Okay. Next we have is, okay, before that we will see the formulas of zero order, first order and second order. Now most important is the formula of first order reaction here. Also remember that units of K is equals to mole per liter 1 minus n per second. And also remember, generally where n is the order of the reaction, T half is directly proportional to A naught 1 minus n. These are the two important things to remember for your questions. if they ask you general units, right, order 1, 2, 3, 4, 0, whatever is given to you, put n value. According to that, you will get the units of K, right? K is the rate constant, right? T half is the half-life period. The general equation is E naught is the initial concentration raised to power 1 minus 1. This is the general equation. Okay, this is the general equation. Now, these two formulas are very important for your, these are most important formulas. And I would say most important is first order, then there is zero order. Least important is second order. Very rarely they will ask you questions based on second order. So first order is K is equals to 2.303 log of initial by final. T half is 0.693 by K. Zero order is K is equals to R naught by R by T. T half is R naught by 2K. Second order reaction is K is equals to 1 by T, 1 by R1, minus 1 by R2. T half is 1 by R naught into K. Right? Okay. Now let us do one question here. Right? Okay. Based on activation energy, firstly we will do. Right? Here you have K is equals to A, E raised to power minus EA by RT, where A is the Arrhenius constant, right? And K is the rate constant, E is the activation energy. Solving this, right, we also get log of K2 by K1 is equals to E by 2.03 R, T1 minus T2 by T1 into T2. Okay, so that also you get here. Now, if you have a question of Arrhenius equation, let's say, for a reaction of H2 with I2, the rate constant is this. The rate constant is given to you at this, and rate constant this at this. That means T1, this is K1, this is T1, this is K2, and this is T2. Right? The activation energy they are asking you. So directly that formula you will put here. Right? Directly this formula you are going to put. Log of K2 by K1 is equals to EA, 2.303 T2 minus T1 by T1 into T2. From this K1, K2 you know, T1, T2 you know, just you can solve the value of EA here. Right? What is the value of R that you will put here? Because things we are solving in energies, we are talking about energies here. So whenever we are talking about energies, we'll put the value of R as 8.314. Okay? We'll put the value of R as 8.314 here. Rest of the things will remain the same. Is that clear to everybody or not? Yes, students, is that clear or not? Is that clear or not? Right? Okay. Very, very good evening. Very, very good evening. How many of you guys, this is clear to how many of you? Right? Directly, it was a formula-based question. Okay. Now we will see question on decomposition of X. Decomposition of X exhibits a rate constant this. You might be like, oh my god, ma'am, what is this? See, decomposition follows which order reaction that you should know, right? So remember that decomposition, right? Either from the units also you should know that it follows zero order reaction. Decomposition reactions are zero order reactions. Now, if you have no idea on that, you can also find it from the units of K. Exhibits a rate constant of this per year. That means UG per year. This is given to you, rate constant of this. How many years are required for the decomposition of 5 UG of X into this? Okay. So this is your final concentration. This is your initial concentration. And this is your rate constant, right? Now from this we already know this is a zero order reaction. For zero order reaction we have seen the value of T half here. We have seen the value of T half for zero order reaction, that is R naught by 2K. What is R naught? R naught is nothing but that is the initial concentration. Okay, R naught is nothing, R naught, A naught, all these are representations of initial concentration. So what do you mean by that? K is equals to A naught by 2K or R naught by 2K. A naught or let's say R naught, that is given to be 5 UG, right? So you'll put it here. The value of K is already given to you, that is 0.05, right? 0.05, and then nothing you are left with. You just have to put this and solve this value, 5 will be cancelled. Here you will have 100. This will be 2. This will be 50. So answer will be 50 years is the correct answer. Okay. Understood everybody? 50 years is the correct answer. Okay. You want me to speed it up? Now we are towards the end of physical chemistry. That is the last question, right? Okay. Last question, last question nahi. This is most important question from your electrochemistry. First topic is Nernst equation. Then 3 topics majorly you have here, right? So first is Nernst equation, that I would say the most important thing here, right? So for that you should know this equation, that is E naught is equals to E naught cell minus 0.059 by n log of oxidation by reduction, right? Now next formulas are these 3 formulas, right? Delta G and E naught cell, delta G and log Kc, E naught and Kc. These 3 equations, directly the formula based questions can be asked here. Then this we have already done, that if you have delta G is negative, if this is negative, right? Let's say if this is negative, E naught is going to be positive. If this is positive, E naught is going to be negative. That we have already done in equilibrium as well. Now next kind of question, that is, what is conservation of energy? Conservation of energy means, if let's say you have A to A positive and A positive to A2 positive. Here you have E naught value is E1 naught, this is E2 naught. And they are asking you for A to A2 positive, what is the E naught value? So you can't just add E1 plus E2. No, you can add the Gibbs free enthalpy here. And that is how you will get, by adding Gibbs free enthalpy, this is the equation that you will get from this formula, because Faraday will cancel each other and minus will cancel. So it will be N3, number of electron exchange, multiplied by E naught 3 is equals to N1 into E naught 1 plus N2 into E naught 2. That is your final equation. Okay, right? Okay, students. Now, next is very simple question based on this Coriolis law and these formulas, right? One is, this is the equation that you should remember from the graph, that is molar conductivity is equals to molar conductivity at infinite dilution minus A into under root C, that is the concentration. Now for strong electrolyte, we can get the intercept here. That's why for strong electrolyte, we don't need Coriolis law. But for weak electrolyte, there is no intercept. So we are not able to find the molar conductivity at infinite dilution. That's why we needed Coriolis law here. Coriolis law simply states that if you want to find the infinite conductivity of a weak electrolyte, that will be equals to the infinite conductivity of the corresponding ions here, right? Okay. Now, if you see, ma'am, how to find out the value of this molar conductivity at concentration C and infinite. Infinite you can easily calculate, but how to find the molar conductivity of concentration at concentration C? For that, what we will do? For that, what are the formulas that you should know is that molar conductivity is equals to kappa into 1000 by molarity. Equivalent conductivity is kappa into 1000 by normality. Kappa is the simple conductivity. And here it should be in centimeters, only then you can apply this formula. If it is in meters, then you will apply this formula. But I would say mostly you will have kappa in centimeters only. So you'll apply this formula, right? This is the molar conductivity at concentration C. This is the molar conductivity at infinite concentration, at infinite dilution. And hence what will happen? From that, alpha you can solve. Alpha is the degree of dissociation. And this formula for weak electrolyte we have studied in equilibrium, that Ka is equals to C alpha square. Put the value of alpha here and you will get the value of Ka here, right? Okay. Now, other formulas to remember here is G into G star is equals to kappa. G is conductance. G star is cell constant, that is equals to length by area. And kappa is the conductivity. Okay, that's a very important formula for you. Then this is the general formula that you have studied in physics as well, that R is equals to rho L by A. But this is very important formula when we talk about chemistry, right? Then, okay. Then one more thing, I'll just write it here, right? Two formulas that also you should know the formula at least. First law of Faraday. First law of Faraday states that W is equals to ZIT. That means molar mass by N factor into Faraday IT. That is going to be the weight deposited, right? If they ask you the weight deposited here, right? Okay, directly you will put this formula, right? That's a very, very important formula. And second law states that, here what you will have, weight of, let's say, two electrolytic cells are in series, right? So weight and equivalent weight, or you can say weight of two A and B will be equals to, the ratio will be equals to equivalent weight of A and B, right? So these are some of the important formulas for your chemistry section, right? Now let us do this simple thing here. That is, this is not related to any of the formulas. Okay, let me tell you, because I need to save your time here as well. So oxidizing power. So these kind of questions repeatedly we see, right, in VITEEE. So what you have to see here is, for example, any of 3-4 options are given to you. They are asking you the oxidizing power. So always remember, reduction potential is inversely proportional to reducing power, right, is directly proportional to oxidizing power, right? That means if someone is very good, I want to get reduced, then I will try to oxidize someone. I am a very good oxidizing agent. So that's why if they are asking you oxidizing power, that means you have to put it in the order of reduction potential. Reduction potential means gain of electron. Everywhere you have gain of electron. The one which has maximum reduction potential has a maximum oxidizing power. So maximum is for cobalt, right? That is having the maximum. Then you have Pb, then you have Ce4, then last one is Bi. So answer will be B is the correct answer. Okay, so that is how you're going to answer these kind of questions. Students, tell me if that is clear to all of you or not, because after that I'm going to start with solid states, right? Then I'll do chemical bonding and coordination chemistry, right? Okay, if that is clear to all of you, then spam this chat box with green hearts, right? So that we can start with solid states here, right? Okay. Yes. Next we have solid states. So in solid states, what if you have never done this, ma'am? I had no idea, ma'am. That was not also there in my board exams, ma'am. Okay. So what if, see, you may be from different boards. So what if that was not there in your board exam? So what you have to do here, right? Then go through this table here, right? If you're like, ma'am, I find this table very difficult, this is a second priority table. This still you can skip here, right? From the questions only, I'll tell you 2-3 kind of questions that can be there in your exam, right? Then there is cubic unit cell, right? So this is your relation between R and A for simple cubic. This is body centered, BCC. This is FCC. Okay, so I'll just write it here. One is simple. One is simple cubic. Then you have BCC. Then you have FCC, that is face center. Okay, so I'll just put it here. Simple. This is BCC and this is FCC. So you should know the relations of R and A here. So what is R? R is the radius of the atom, right? When there is a cube, right? The radius of the atom that you're putting it, right? So that is the radius, R. A is the edge length of all the sides of the cube. That is your A. Okay, so you have to know the relation between A and R here. Packing fraction, directly you can just cram it also, that FCC has a maximum packing fraction, then you have BCC, then least one is for SCC, right? Coordination number is 6 here, is 8 here, is 12 here. If you understand, ma'am, how it is so. See, for FCC, if you see, there is the atom in the face, right? On the faces, let's say first we talk about BCC. There is atom on the body center, right? Okay, and then there are how many atoms on the corner? 1, 2, 3, 4, 5, 6, 7, 8. Right? So 8 atoms are touching this body centered atom. So that is why coordination number is 8. So to that body centered, 8 atoms are occupying it. Right? If you talk about the face center, right? In that case, what you will see, if let's say it is on the face, right? It is on the face. Face means, let's say this is the, if I say this is the face means this length, okay? If here you have one atom, here you have one atom, how it is touching different atoms here, right? So what you will see here, right? Just imagine this in your room, right? You have this side wall, you have one atom, right? That and other atoms are there on the corners of the wall. So now this center atom will touch how many atoms here? 1, 2, 3, 4. 4 corner atoms of this room, 4 corner atoms of other room, 4 corner atoms, 4 corner atom of this room and the other room. That is 4 plus 4, 8. Right? Now what you will see, that corner atom, it is touching how many things? Again, it is touching 4 different atoms here. Right? So that corresponds to 4 plus 4 plus 4, that is 18. Effective number of particle is 4. Coordination number in case of simple cubic center is 6. So directly, you can also remember this, okay, directly. Either the direct questions will be asked to you or numerical based questions will be asked to you. Next is density. D is equals to Zm Na cube. This I'll tell you how to apply this. That is effective number of particles. According to this, whether it's simple BCC, FCC, you will have your value of Z here, right? Then you have mass is the molar mass that will be given in the question. Na is the Avogadro's number, A is the edge length. If directly edge length is not given to you, they will give you the radius. From there, you can calculate the edge length depending upon the formula, depending upon which cubic cell you have. Whether it's simple, whether it's FCC, whether it's BCC. Now, I'll tell you one question based on this. What kind of questions they can ask you? Let's say at 100 degrees Celsius, copper has FCC unit cell structure with cell edge length X. What is the approximate density of copper at this temperature? They are asking you the density, okay? Copper, we know the molar mass of copper, right? FCC unit, they are asking you. With edge length is also given to you, that is X. Okay, in terms of X, you have to tell what is the density. So directly what you can say that for FCC, unit cells Z is equals to 4. That we have seen. Mass atom, that also we know. Number of Avogadros, we also know. Now, edge length is there in angstrom. You have to have this edge length in terms of centimeter because this formula has edge length in centimeter. Right? That is the major mistake that students might do here. Right? So, edge length is in centimeter here. Right? Now, density is equals to Z you have, M you have, Na you have, A you have. Now, you solve this and you will get your answer, right, in gram per centimeter cube. Is that clear to everybody? This is the direct formula that will be applied here. Right? Very simple questions they will ask you here. Right? Next is the arrangement of X negative. Now, it's a very interesting question. Okay. So, every single question is telling you something else about the topic. Right? The arrangement, let's say they have given you this, firstly from this arrangement, these are questions related to voids, okay? So, the arrangement of X negative around A positive, this is X negative and this is A positive. Solid AX is given in the figure, not drawn to scale. If radius of X negative is this, the radius of an ion VITEEE bond. Now see, first we have to see whether it's octahedral or a tetrahedral void. Now anybody in the chat box, directly from the figure you can tell whether it's octahedral or tetrahedral void. Okay, so that is your octahedral void. Okay, these kind of figures are for octahedral void. 3 in front, 3 in back, that is the octahedral void. Okay, because you have basically you have 8 phases that are occupying here, so that is why it is octahedral void. You don't need to get into the reason here. Just see, this is octahedral void. This kind of position is octahedral void. Now, for octahedral void, R of cation by R of anion is 0.401. That is the formula. right? So R of cation, you have the value of R of anion here. This you have to calculate. So directly you can put the values and calculate the answer here, right? Okay. Okay, students, that is clear to everybody? Yes, student, is that clear? Now let us see 4 topics which are definitely will be there in your exam no matter what. These are those 4 topics that it's like no chemistry exam is formed without these topics, right? Okay. Firstly, though, I'll just advise you guys that I would suggest you to go through. I'll start with VBT, right? Okay. So first is your VBT, that is from chemical bonding, right? So here what you have to see is different concepts here regarding the shapes. Okay, so are you all ready? Everybody, if you guys are ready to brush up your concepts, and let me know in the chat box, right? Let me know in the chat box if you guys are ready to brush up your concepts of VBT West. So now how you will identify the shapes? First thing is, if your sigma plus lone pair is equals to 2, it is SP. It is 3, it is SP2, 4 SP3, 5 SP3D, 6 SP3D2, right? For SP it is linear, SP2 it is trigonal planar, SP3 it is tetrahedral, SP3D it is trigonal bipyramidal, SP3D2 it is octahedral, right? Now, remember that whenever we are doing shapes, we will only calculate bond pairs. For geometry, we will calculate both bond pairs and lone pairs, both of them, right? Now, one by one, we will do this. Let's say you have AB2 kind of molecule, right? Let's say you have AB2 kind of molecule, that is a simple molecule like this. Okay, I'll just show you. AB2 kind of molecule is a simple molecule like this, right? So if you have no lone pair, AB2 is a linear, right? If you have one lone pair, that means you have to ignore the lone pairs in shapes. So that will again be a linear shape only, right? Okay, so that means shape is going to remain linear only in this case. Next is AB3. AB3. Now, here, if there is no lone pair, it is a trigonal planar geometry as well as shape. But if let's say you have one lone pair, that means this is a bent V shape. Geometry will remain the same, but shape has changed, that is bent V. Let's say you have two lone pairs, in that case, you will have linear shape here, right? Okay. Next, students, next one is your tetrahedral. This is a tetrahedral, okay? This is tetrahedral, right? So if you have all the 4 bond pairs, it is tetrahedral. If let's say you have one lone pair, in that case, it is now a pyramidal shape, right? So that is why it is pyramidal. Let's say you have 2 lone pairs. With 2 lone pairs, now the shape is bent V, right? Okay, bent V. As you can see, it was like this, so it is bent V. Then if you have 3 lone pairs, take out one bond pair, and that is going to be your linear shape, right? Okay. Next, what we have is SP3D. So what is SP3D? Everybody in the chat box, what is SP3D? What is SP3D? Everybody in the chat box. Here you have one trigonal. This is the triangle that you will have, and 2 pyramids here. Okay, 2 pyramids here. So it is going to be trigonal. This is trigonal bipyramidal. This is first pyramid, and this is the next pyramid. Trigonal bipyramidal. Okay, trigonal bipyramidal, 2 pyramids you will have here. Now, very important thing is that if you have 5 bonds, then it is trigonal bipyramidal. What if you have one lone pair? Lone pair, see, these 2 positions, the pyramidal positions are the axial positions. These positions are the equatorial positions. So that is the reason Here, always in this position, you will have the lone pair. So if you have one lone pair, that will be on the equatorial position. That is why you have a seesaw shape. Okay, as you can see, this is a seesaw shape. Okay, this is a seesaw shape. Next is, let's say you have two lone pairs. Again, second lone pair will also be on the equatorial. So this is a T shape. That's why it is a T shape. Again, if you take out one lone pair more, that is from the, you make one more lone pair on the equatorial position, that will be a linear shape. So hence it is linear. This is a very, very important thing. Okay, this is most important AB5 kind of molecules, right? Next is octahedral. So ready for octahedral, right? Everybody ready for octahedral? Now I want to see you telling me in the chat box what is octahedral, right? Everybody, I want to see you guys tell me in the chat box what is octahedral. Is this an octahedral position? Stop simping. Okay, what is octahedral? Yes, everybody. This is octahedral position, right? Now here, as you can see, this is one square, two pyramids here, right? We call it octahedral only. If you say you have all the 6 bonds pair, this is octahedral. If here you have one lone pair, then you take out one lone pair, this is square pyramidal. That's why here it is square pyramidal. If let's say you have two lone pairs, that is called square planar. That is why it is called square planar here. Is that correct? Is that clear to everybody or not? I can see you guys are not interested. Ma'am, we want VITEEE session, ma'am. You take the session, we won't be interested at all, ma'am. Next theory is molecular orbital theory. Here what you have to remember. So before this, I'll do the questions of, let me see. Okay, so I don't have questions related to that, but I'll just solve one question here related to that. Let's say we talk about SO2. Okay, so you have this molecule, they're asking you what is the hybridization here. So how you will calculate? Firstly, you will see central metal atom, right? Then you will see that how many, to which group it is belonging to. Sulfur is belonging to group number 16. Okay, so you will say 6 outermost electrons you have. Minus, we know that oxygen always forms double bond. Oxygen always forms double bond. So this is 1, 2, 3, 4. 4 electrons are occupied in making the bond pair. So it is only 2 electrons you are left with. That is one lone pair you are left with. One lone pair you are left with. Now, what we will have here? Now, students, this is S double bond O. Double bond O. How many sigma bonds you have? 2 sigma bonds. How many lone pairs? 1. So it is 3. 3 means sp2 hybridization. Okay, that means it is going to be something like this, S1, 2, 3. Okay, so we know that you have 2 double bond O, so I'll write 2 double bond O here and 1 lone pair, so 1 lone pair will be over here. That is how you will get the shape, that is bent V. You will get the hybridization, that is sp2. Okay, is that clear to everybody or not? Students, is that clear to all of you or not? Then let me know in the chat box if that is clear. Right? Now let's solve one more question like this. Right? Let's say they are saying that solve for HCF4. Okay. In this case, xenon is belonging to which group? It belongs to group number 18. That means 8 outermost electron. 4 are already, because fluorine always makes a single bond. So it is already occupied in bond formation. You have 4 electrons. That means 2 lone pairs you have. Now students, for 2 lone pairs, what you are going to do here, very simple thing. 2 lone pairs, ma'am, we have here. 2 lone pairs, ma'am, we have here. So this is going to be sigma bond is 4. 2 lone pair, it is going to be 6. That is sp3d2. Right? So that means xenon 1, 2, 3, 4, 5, 6. That is the octahedral game. Right? Now here you have 2 lone pairs that I'll put here. 1 here, right? 1 lone pair here, and lone pair should always be opposite. You can't put 1 lone pair here and 1 here. That will cause a repulsion. That is why Vesper theory states that lone pair repulsions are greater than bond pair are greater than lone pair are greater than bond pair lone pair are greater than bond pair. So we will not want two lone pairs to be together. That was the same reason why lone pairs were on the equatorial position. Okay, so this is F, this is F, this is F, this is F. This is the square planar shape and octahedral geometry. That is how you will answer the questions related to shapes and hybridization from chemical bonding. If that is clear to all of you, then let me know in the chat box. Next very important concept is MOT, molecular orbital theory, right? Here, when two orbitals, atomic orbitals overlap, they have bonding molecular orbital and anti-bonding molecular orbital. Two things are formed, right? Now here what you should remember, that for bonding molecular orbital, everybody over here, right? Everybody over here, right? Okay. Now here, if you see bonding molecular orbital, right, that is going to be lower in energy as compared to anti-bonding molecular orbital. Now what I have written here is less than or equal to 14 electron, it is 2-1-2-1. If you have more than 14 electron, it is going to be 1-2-2-1. Okay, so simply what you will do here, very simple thing we will do here. First thing is, always remember there will be a KK star. That means it will be KK dash. That KK dash will have 1s2, or you can just write sigma 1s2, sigma star 1s2, sigma 2s and sigma star 2s. So why we will not write it, right? Because already we will write KK star which has 8 electrons. So you can just write KK 8, right? That means already you have picked it, because if you have atomic number more than 8, let's say you have more than 8 electrons, then already this whole shell is filled. So you don't need to write it again and again. So now we will use the tricks here. How to solve this, right? We will use the tricks here, right? I'll explain you with the examples here. So let's do questions. From this question, I'm going to explain you 3-4 things. So see these questions very carefully, right? What is the number of unpaired electrons in the highest occupied molecular orbital of the following species, right? So two things are, first is you have to calculate for N2, right? Now, firstly, you need to tell me, they are asking you highest molecular orbital. See, here you can't use any trick. You have to solve the diagram, but diagram also we will do easily, right? So N2 means 7 plus 7, that means 14 electron. As I told you, KK shell you will already eliminate, that is 8 electron is there in KK. So you will already eliminate the KK. So that is going to be 6 electrons you are left with, right? When you have 14 electrons, that is when you have equal to 14, you have 2-1-2-1. What is 2-1-2-1? 2-1-2-1 is this, 2-1-2-1. I'll tell you after this what exactly 2-1-2-1 means. Now N2 positive means how many electrons you have? This is 14 electrons minus 1, that is 13 electrons. From 13, 8 electrons are already there in KK. So this is minus 8, that corresponds to 5 electrons, right? Okay. Now again what you have here is, now here what you will see, whether it's 2-1-2-1 or 1-2-2-1. Important thing is, don't look for this N2 positive. Okay, don't look into this N2 positive that it has 13 electron less than 14. No, that is a wrong thinking. N2 positive, the neutral species of this N2 positive is N2, which is having 14 electron, which is equal to 14. That is why it will have 2-1-2-1. Because N2 positive has 13, that is not why it will have 2-1-2-1. Because the neutral species has 14 electrons, which is equals to 14, that is why it will have 2-1-2-1 here. So you'll have to look for neutral species. Okay, that is why again it will be 2-1-2-1. Now electron filled is, here you have 6 electrons, 1, 2, 3, 4, 5, 6. Here you will have 1, 2, 3, 4 and 5. Now they are asking you the number of unpaired electrons in the highest occupied orbital. Now students, see one thing here. What is the highest occupied orbital? This is the highest occupied orbital. This is the highest occupied orbital. This has one unpaired electron. This has zero unpaired electron. So this will be 0 and 1. This is going to be 0 and 1. 0, 1, 0, 1. So this is eliminated. This is eliminated. Right? Now one more thing here. Now what is this dash, 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 dash? So always remember, sigma is Z, pi is x and y, and x and y is always going to remain the same. So here how we will write this? This is 2 same, that means this is 2px, this is 2py, because this is pi, so it will be pi 2px, pi 2py, which are equal. These two are also pi 2px, pi 2py, but they are anti-bonding. This is anti-bonding, 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 this is anti-bonding. Right? So here it is, single one is Z. So it is sigma 2pz. Ma'am, how to remember this? See, who is single person? Who is a single person? Who is sigma? A sigma person is always a single person. So sigma, that is 2pz is sigma, that is why it is single. Right? But this 2px and 2py are QT pi's. So that is why they are not able to remain single. That is why they are 2px is equals to 2py, they have the same energy. Okay, so this is how you can remember this. And same is thing for this 2p, this is star, this is pi 2p x star, pi 2p y star, this is sigma 2p z star. Okay, understood? Now we'll do the same thing for O2. Okay, we'll do the same thing for O2 here. Okay, for O2 also we will do the same thing. Let's do that. Now let me see how many of you are able to tell me the answer between A and C. Right? So very slowly I am doing this. O2, how many electrons? 8 into 2, 16 electrons. 8 electrons in KK, you are left with 8 electrons. O2 positive, how many electrons? 15 electrons. 8 electrons are occupied, so this will have 7 electrons. Right? Now, what you will see, 8 electrons and 7 electrons, because originally both are 16 electrons, so it will follow more than 14, that is 1, 2, 2, 1. So it will follow 1, 2, 2, 1. That means it will be like this. It will be like this, that is 1, 2, 2, 1, 1, 2, 2, 1. Okay. Here it is 8 electrons, 1, 2, 3, 4, 5, 6, 7, 8. Here it is 7 electrons, 1, 2, 3, 4, 5, 6 and 7. So O2 has how many electrons? Unpaired electrons? 2. This has 1 unpaired electron, so it will be 2, 1. So answer is going to be A is the correct answer. Is that clear to everybody or not? How you are going to solve the questions of MOT? Now one very important thing regarding MOT, let's say they ask you the bond order, right? So always remember, for 14 it is going to be 3. For 14 it is going to be 3. Rest of it is, if it is increasing 15, 16, 17, 18, or it is decreasing 13, 12, 11, 10. Right? What you are going to write here? This will be 2.5, this is 2, this is 1.5, this is 1. This is 2.5, this is 2, this is 1.5, this is 1. Okay, that is how you will get your bond order. Otherwise, the formula of bond order is number of bonding minus number of anti-bonding electrons dividing by 2. That is the formula of bond order here. Okay, but this trick will really help you to solve the questions easily and in a quick way. Right? Okay, students, is that clear to everybody? Now let us do the concept of coordination compounds. Like coordination compound, first are these exceptions that you should know when you are writing VBT questions, okay? Because if you are just solving the questions as it is, but you don't know the VBT, the concept of like the exceptions, then chances are you might do the answer wrong, okay? So remember that cobalt 3 positive with H2O and oxalate, then ligand act as strong field ligand. Right? Water and oxalate usually are weak field ligand, but if they are bonded with cobalt 3 positive, they will act as strong field ligand. Right? Cu2 positive, when it is bonded with H2O, it is acting as a strong field ligand. Water also is a weak field ligand, but with copper 2 positive, cobalt 3 positive, it is acting as a strong field ligand. Okay. Nickel, fluoride is a weak field ligand, but with fluoride, with Ni4 positive, it is acting as a strong field ligand. Okay. Then iron and manganese, right? When they are bonded with NH3, right? Then it acts as a weak field ligand. Now we know that NH3 is a strong field ligand. It will cause the pairing, right? But with Fe2 positive and Mn2 positive, it is acting as a weak field ligand, right? Next is this you don't need to know for this you can ignore, right? For this concept, you just need to know these important parts. Okay. Understood? Yes, everyone? Okay. Now I'll start with the VBT questions. See, from the question only I'll tell you how to answer that. Only from the questions, right? Because theory is not important here. The important part is steps. Okay. So the pair having same magnetic moment, right? So they have given you two pairs here. So what we know here is that water, see, first you have to, let's say I want to calculate CrH2. Okay. So firstly I'll calculate the oxidation state. That is going to be X plus 0 is equals to plus 2. So cobalt is in plus 2 state. So cobalt in plus 2 state means water will act as a weak field ligand. Cobalt in plus 3 state, water will act as a strong field ligand. So here it is weak field. So here it is, sorry, it's not cobalt, it's chromium 2 positive, right? So now here you should also know one more thing that I'll just write it here. Saktiv Karman P Konikujan. Okay. The electronic configuration, this is 21, 22, 23, 24, 25, 26. This is 27, 28, 29, and this is 30. Electronic configuration is 4s, 4s, you write 4s, 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 4s. This is 4s, 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 4s. You write 3d, 3d, 3d. Write 3d everywhere, yaar. Okay. Then I'll just directly tell you, because if you know these electronic configuration, you can answer things. Otherwise, there is no use of doing this theory, right? Okay. Then 21, 2, 1. So 2, 1. 22, 2, 2. 23, 2, 3. But stop at 24 because of half-filled electron, it will be 1, 5. Okay. Then you have 25, 2, 5. 26, 2, 6, 27, 2, 7, 28, 2, 8. 29 is again stop there with copper. It is 2, no, it is 1, 10. That is how you have 29. Okay. Then 30 is nothing but it is 2 and this is 10. So that is going to be your electronic configurations. Okay. If you know these electronic configurations, directly you can answer it, right? Now, with chromium, we know that chromium is what? 24. 24 is 4s1, 3d5. You take out 2 electrons, it will be 3d4. Now, there is no pairing of electrons here because it is a weak field ligand. That's why number of electrons, number of unpaired electron is 4. Right? With cobalt, now I'll solve for cobalt. This is X minus 4 is equals to minus 2. Again, it is cobalt plus 2. Right? Cobalt is 27, that is 4s2, 3d7. You take out 2 electrons, it will be 3d7. Right? 3d7 means 1, 2, 3, 4, 5 in 5 orbital, 6, 7. 3 electrons are unpaired, that means here it is 3. So this does not have same magnetic moment. For same magnetic moment, number of unpaired electrons should be same. Right? Here we have already calculated it was 4. Let us calculate for iron. Iron here exists in iron 2 positive. That means it is 3d6 because 2 electrons you have taken out from 4s. Electrons will always be taken out from 4s firstly. Okay. So here no pairing of electron 1, 2, 3, 4, 5 and 6. That means total 4 unpaired electrons. So answer is B is the correct answer. Okay. One more thing you should remember for this pairing and unpaired electron is mu is equals to under root n plus 2 Bohr magneton. But you don't have to use this formula. Okay, you don't have to use this formula. Directly what you can do here is, if number of unpaired electron is 1, 2, let's say 3, let's say 4, let's say 5, then the answer is going to be 1.7, 2.7 or 8, like whatever you feel is more easy. 3 point, let's say I'm writing it as 8, okay? Wait a minute. Okay, 3.8, then you have 4.9, then you have 5.9. Okay, this is what you will get your answer for unpaired electrons here. Right? This is number of unpaired electron. This is mu. Directly you can answer this. Okay? Understood everybody? Next is last topic, that is CFT, crystal field theory. Okay? Crystal field theory, because I think you guys are quite exhausted. So what I'll do, let me know in the chat box. So I'll do this, I'll tell you this after this session only, right? Crystal field splitting in octahedral complexes, okay? In octahedral complexes, what is the crystal field splitting here? So what you have to do, this is dxy, dyz. In octahedral splitting, what will happen? You will have 3 orbitals and then you will have 2. That means C2G, then it will be 2G, okay? And whenever there is strong field ligand means there is large splitting. In that case, electrons will be filled like this: 1, 2, 3, 4, 5. Okay. But if there is a weak field ligand, which will not cause that much splitting, in that case it will fill like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is how you're going to fill this. Understood? Right? Now, next is for tetrahedral splitting, you have opposite. This is E and this is T2, right? And in tetrahedral complexes, usually the splitting is not very high. Okay. Now, one important part to remember here is, see, if you have CFSC is very high, in that case your gap is very high. The gap is very high, right? In that case, you will have pairing and you will have no pairing. Okay, it will not try to cause any pairing, but the splitting is very wait a minute, it will try to cause pairing because the splitting is very high. Yes, splitting is very high, that is why it will not go to the further next level. It will try to cause the pairing. That is why you will have low spin complexes here. You will have low spin complexes. And opposite here you will have, if CFSC is high, that means you have a strong field ligand. Okay. Then opposite is for this. If your CFSC is low, gap is low, you have weak field ligand. That will cause high spin because there will be no pairing. That is why there will be high spin complexes will be formed here. Right? Okay, students, understood? Now we will see some questions here, right? So there is a spectrochemical series given in your NCERT. Okay, follow your NCERT for the spectrochemical series. From here, what kind of questions they can ask you? Identify the correct trend given below. So they are asking you the correct trend here, right? This is delta O of this and this, right? Okay. So in this case, you should know the CFSC trends. Okay. So here chromium and molybdenum you have. Here you have titanium and titanium. So here your ligand is changing. In this case, the oxidation state is changing. So more is the oxidation state, more will be the CFSC. Okay. So that is why what you will see, that more is the oxidation state, more is the CFSC, this one, and this one will come out to be the correct one. This one will be eliminated. So as oxidation number of the same atom increases, CFSC increases. That you should remember. I'll just write it here. CFSC is directly proportional to oxidation number. Right. Next is, this is chromium, this is molybdenum. Right. So chromium 3D, 4D. So as you go down the group, CFSC increases. 3D, then 4D. That is why here C is going to be the correct answer. Got it? Understood? As you go down the group, CFSC will increase here. Next is question based on how These are very, very important questions, right, based on CFSE. Usually these were ignored before, but now they don't ignore these kind of questions, okay? So I think that is the last or maybe the second last question, okay. Now, crystal field stabilization energy for high spin D4 octahedral complexes. High spin D4. See, you have octahedral complexes are like this, okay? Now here, D4 means high spin means high spin. See what you have seen here for high spin. What I told you for high spin. For high spin, your gap is going to be low. Right? That means there will be no pairing in this case. Right? So it will be like this. 1, 2, 3 and this is 4. Now, this is a barycenter. From here you have certain gap. Right? So here this is 0.6. Positive of 0.6, this is the gap. It is minus of 0.4 in case of octahedral complexes. So that is why 3 multiplied by minus of 0.4 plus 1 here you have 1 electron, right? So this is multiplied by 0.6. So this is minus 1.2 plus 0.6. Answer is minus 0.6 is your correct answer. So answer is minus 0.6 delta O is for high spin D4 octahedral complexes. With this, they can ask you anything, high spin, low spin. If they ask you low spin, in that case, instead of this electron, it would be here. Then you will have answer as, this will vanish off, you will have 2 into minus 0.4. Then that would be your answer, okay? So according to that, you will have your answer, right? Next we have is, which of the following statement is false? 4 statements they have given you. Let us see how many of you are able to answer this. Let us see that. First is, in an octahedral crystal field, the electrons on a metal ion occupy EG set of orbital before occupying T2G. See, no, that is not true, because in octahedral you have 1, 2, 3, 1, 2. This is T2G, this is EG. So they occupy T2G firstly, because that is low in energy. So that is the false statement. That means this is the correct answer. Next is, diamagnetic metal ions cannot have odd number of electrons, right? Diamagnetic means all of them are paired. So pairing means, if I say 5 couples, so that means 5 into 10, 10 persons will be there. So that means they cannot be odd number, yes. Low spin complexes can be paramagnetic. Low spin means they that are pairing of energy basically is there, can be paramagnetic. Yes, it can be, it will not always be paramagnetic, but it can be paramagnetic. They're not saying always, right? In high spin octahedral complexes, high spin octahedral is less than the electron pairing energy and is relatively very small. Wait a minute. In high spin octahedral complexes, high spin means where your weak field ligand is occupied there, right? Weak field ligand. Octahedral energy is less than the electron pairing energy. Yes, delta O is less than pairing. That is why in high spin complexes, because delta O is less, but pairing energy is very high, that is why it will not cause any pairing. So that is also the correct answer. Okay, so correct answer will be A, but the correct statements are, all of these are the correct statements. Okay, understood everybody? Yes, students. Now, to all my students here, right? Now for inorganic chemistry, I have put some notes for you in this PDF. In this PDF only you will get some notes here, right? Regarding the exceptional trends, I have written everything here, right? And then I have also written, because trends are what is there to explain, okay? This is the trend, right? So that you have to do yourself, right? And these are the important trends, right? And these are some of the questions, 5-6 questions based on those trends. And don't forget to do this table, okay? This table, I'll just explain you what you have to do here. You have to do the electronic configuration of lanthanum, of cerium, of terbium, of gadolinium, europium, then ytterbium, then lutetium, right? Ytterbium is stable in +2 oxidation state. Terbium is stable in +4 oxidation state. Gadolinium is stable in +3 oxidation state. Europium is stable in +2 oxidation state. Cerium is stable in +4 oxidation state, that you should know. Lanthanum is stable in +3 and deuterium is stable in +3. So these are some of the very, very important electronic configurations for you, right? Very, very important. But if you don't want to take any risk, you can also do for neodymium. That also is one of the previous year questions, right? Then where is samarium? Samarium. Okay, this if you want to do, you can do this as well if you don't want to take any risk. Otherwise, these that I have marked with red, this you can't skip. Okay, in the oxidation state in which they are stable in. Okay, understood? Right. So now here they are, which of the following is likely to deviate easily from +3? That is cerium, because it is more stable in Ce4 positive. Rest of these three are stable in +3 oxidation state. Lanthanum, lutetium, C. If you see this here, lanthanum, gadolinium and lutetium, these are stable in +3 oxidation state. Okay, so these kind of questions they are asking, right? Then students, one more thing on this channel only for your preparation, right? Here what you will see on the video section, right? Physical chemistry formulas, so I have already done, but still if you want to see all the physical chemistry formulas that are there in this channel, on this video section, JEE 2023 April 10 physical chemistry formula. Solid state I have completed, that was not there. Right? Then next one is your live section. I know you guys are thinking about, ma'am, what about organic chemistry, ma'am? How you can skip organic chemistry? So today only, right, before sleeping, if you are an early bird, then you can wake up at 6 p.m., right? Sorry, 6 a.m. and start your organic chemistry, because I don't want to repeat the same things again and again on this channel, right? That would be really wasted of your time and my time as well, right? So here if you see, because I am not going to change the reactions for VITEEE, there are different reactions. For JEE, there are different reactions. The reactions are same. The syllabus is same, right? So go through this all naming reactions, organic chemistry, this one. All naming reactions, organic chemistry. And also here I have done reagents. This is just 1 hour 40 minutes lecture. Go through this lecture, so that once you have completed this lecture here, then let me know in the comment section. See, only if you demand, only then I'll take this class. Once you have gone through the naming reactions, then I can take one thing for you that will be different for JEE Mains and that will be different for VITEEE. That is how they ask you questions. Okay. So if you want me to take up question session, especially of organic chemistry, that will be entire organic chemistry, right? I'll do that, right? For your VITEEE, especially for VITEEE, only if I see, let's say, 70-80 comments in this video, only then I'll take this on Friday. Okay, on Friday, then I can take this in the morning. Because I'm free in the morning, so I can take this in the morning at around, let's say, 12 p.m. I can take this. Okay, so if you are actually willing to be there in the class, around 70-80 comments I want. If there are no 70-80 comments down on this video, then I'll assume that, okay, you are feeling that, ma'am, no, we are okay with naming reaction and important reagents. We don't need any session for that, right? And if you want, then definitely I can take that, right? Okay. So tomorrow, students, I have my class on NEET, so I can't take that, right? Otherwise, I would have loved to take in that class, right? Now here, this organic chemistry, and then there is for inorganic exceptions also. I didn't do it in this lecture. Reason being, because I have already done the same exception. See, all exceptions in one go. So here also, this is just 1.5 hour, 1 hour, 30 minutes lecture. So you can do that all exceptions in one go. In detail, I have completed that, right? Okay, so these two things are very important for you to do it today itself, right? So that this lecture that we have done today, that will be completed. Okay, yes, everybody? Yes. So that is all for this thing. And one more thing, that all the students who are like preparing for VITEEE, so here are some crucial in-depth topic that we have taken also for you. Now, if you're preparing for any other exam, let's say SRM, VITEEE, Comet K, any other exam you are preparing for. So these are the test series according to different exams. And if you are preparing for JEE Advanced, I can see some of the students, they were asking for JEE Advanced lectures. The lectures are going there. Don't worry about that. Lectures are definitely going there, right? So if you are preparing for JEE Advanced, so there is a very interesting book for you, that is JEE Rank Accelerator book, that is just at 1665, right? So in this book, you have really interesting questions. And if you want to see the sample of those questions, you can go and watch my lecture of organic chemistry questions, physical chemistry questions I have already taken up. And soon I'll be taking up JEE Advanced inorganic chemistry questions as well. And if you're like, ma'am, my JEE Advanced level is not so good, then there is this batch, that is Eklavya batch going on, where full on revisions, right? Full on revisions, then previous year question discussions, right? And then Eklavya question discussion is also going on in this batch, that is specially designed for JEE Advanced students. Okay, and that's it. So now I'll take your leave, students. Now let me know in the comment section if you want me to do questions on organic chemistry and surface chemistry, because today I didn't take the questions of surface chemistry. So if you want me to take the lecture, like proper dedicated question based lecture on that, no theory will be there. Theory I have already taught you where you are going to do. If you want me to take that and you will be there in the live session, then write down. Right now I'll end the stream. After 2-3 minutes, you will be able to write down the comments. I want at least 100 plus comments on this video so that I can take the session, right? Okay, because as you know that I'm already occupied with so many things, but still I'm willing to teach you if I see the audience is there, the students are willing to see. The students are willing to, invest their time, then definitely I would love to teach you. But the condition is that definitely your motivation should also be there, right? Okay, so chats will definitely fade out, but you have 1 day still to think about that. But yes, 100 comments should be there before tomorrow's like morning or afternoon, so that I can also prepare my lecture for organic chemistry. It takes a lot of time to collect questions for you, especially for VITEEE, right? Okay, yes. Okay then, bye-bye students, bye-bye, take care, see you all in the tomorrow's class, where I'm going to take up UGEE class, right, for your different questions, and really interesting, awesome questions will be there. So your JEE Advanced students can also watch that lecture, okay? Till then, bye-bye, take care, see you all in the next class. Bye-bye, this is Diksha Kaushal signing off. Bye-bye.